Hello everybody, welcome back to Advanced Programming BZAN. This is Professor Xiao Ma. It's already April and semester has finished almost 3 months, and there's only less than a month to go before this course ends. I know that you can almost feel the end of the semester. In this class, I have seen the programming skills and most importantly, the understanding of how it works. In a lot of you made great progress. I have seen a great progress in a lot of you. I like to congratulate very much about your achievement. This is not easy, as you know, and you have all progressed this far. Only a few of you walked into the class with quite good Python background. Most of you don't have any Python background. Some of you might have practiced a little bit, but learning by itself is a little hard without guidance. I'm very happy to see the achievement that all of you have made so far. I know that you can almost feel the end of the semester. You're currently learning Module 9, and soon you'll be learning Module 10. And as we will see, Module 9 and 10 are continuous, so they are together. And even in Module 9, you are seeing how to put things all together and how to use pipeline to clean up your codes and process and make things streamlined. And this is an important step in learning how to manage the business analytics projects by using Python programming. And I have also heard some feedback about this course, and I very much appreciate all of your feedback. One of the feedback is that this course is quite tough. There are so much materials to absorb and so much to learn. And I agree with you. And that is why I like to clarify a little bit about why this course has so much stuff to learn and it's quite tough sometimes. This course was developed and is still being developed for Business Analytics Master of Science students in Bauer College. This course is one of their core courses, but this course is supposed to build a solid foundation for BZAN students so that they will be well versed to meet the challenges out there in data science and working side by side with data scientists, data engineers, or computer science engineers and economists. Without a solid understanding of how Python works with those important objects, including series, data frames, and graphing objects, you will feel not welcomed by them. You will eventually have to put in this much of homework to push yourself and try to understand all of these. So in order to achieve this, as the designer of the course, I would have to include materials on how to learn Python from beginning and all the way up to that you are almost medium level, knowing how to use Python to solve business analytics problems by the end of the semester. I'm sure that by now you feel very confident and fluent with the Python skill sets and objects that you have learned so far, and that is great news. You have put in the hard work, and this is the time that you integrate them all together and take the next step to take it all in and practice them in the final project as well as the final exam. I hope the end of the semester process will be very fulfilling, very rewarding for you, given that you have put in so much time and effort, and now you will be rewarded by the enjoyment of using them at ease. And at this unprecedented time, I would like to encourage you to invest your support for the college and the university by providing valuable feedback to the official course evaluation for this course. Keep in mind that this is a difficult time, and a lot of the students are facing difficulties in trying to be connected with their instructors and the college. So the college would like to know, how the course has progressed through the difficult time and how I did as an instructor to meet the difficulties of the time. As far as I believe, every single student of this class is maintaining a connection with the course, with the learning objective. With me personally, we use Zoom sometimes to troubleshoot questions, other times in emails and broadcasts notifications. I'm proud to say that all of you have not been disrupted in terms of your learning process and work progress in this course. I'd like to congratulate you. Now it's time for you to invest in your just a couple minutes time and help the college and my department and as well as me to understand how you think about this course by taking the official course evaluation. By the end of this video, I will talk about how to find that link in Blackboard course by the end of this video. Since we're in this video, I also would like to show you a few skills that I would like to share with you. As you know, a big part of my research work is dealing with data and cleaning data and preparing the data, then analyze the data. And you know that data pre-processing and data cleaning and data wrangling constitute almost 60% of a data science project time on average. So this part is not to be underestimated. And I can imagine the same thing will happen during the final project process. So that's why I would like to share with you a few things that I routinely use and find useful during the process of my work, so that it will help you improve the efficacy of your project process. Okay, now I have launched my Jupyter notebook, as you can see here on the screen, and I've also imported the necessary packages. I have imported the data frame as an example. You should be very familiar with the MPG data frame. And I have printed a few of the rows in the data frame MPG. A lot of times you find that the data set that you are given doesn't have an ID column, and a lot of times you will need such a unique identifier to make sure that some of your operations are correct, so that you can check on specific rows of the data set to verify that the operations are correct. What if the data set that you are given doesn't have a unique identifier? One way that you can quickly do it is to assign a numeric natural number sequences as a unique identifier to each of the rows. And how can you quickly do it? You probably are thinking about using a for loop and use I as a counter and then assign the I to the column. That's a great thought that can solve your problem, but that probably needs a bit more time to program and probably is more error prone. You may get some exceptions, errors have to deal with. Eventually you will get the result. But I will show you a very quick trick here to quickly do it. And actually you have been doing this in one of the homework, but the purpose was not to create the ID column, but just to recover the ID column. Here we are going to make a unique identifier by leveraging the data frame method of reset index. So we're going to use reset index to create a unique identifier. And before you do that, I'd like to caution that the assumption is that when you import an index, the dataset didn't come with an index value from in the dataset, and you did not plan to import an index. So we're going to leverage the natural sequence of the automatically assigned index values by pandas package, and to rename that column from index to ID after reset index. Here it is. So I have written here mpg.resetIndex, and I have put in an argument here saying drop equal false. What this does is it will make sure the index, the original index value, will not be dropped. The column of the additional index value will not be dropped. However, this argument is by default will kick in, and default value of drop is false, so you can feel free to ignore it. And by calling reset index method of the data frame mpg, it will create the additional column by inheriting the values of the original index. Now, since the index will be reset, the new index will be assigned, but the new index will be the same as the original index because the index was automatically assigned in the first place. And your purpose here is to get the original index values and cast them into an ID column. And here I'm assuming that the ID column is numeric. In most cases it is. However, a lot of times the ID column is string value. So in that case, you would need to recast the integer values into string values, and I think you know how to do it simply by using as type. Now here, if you call this, you will get a new data frame with a new column that says index on a column later label, and you don't want that. You want that label to read as ID. So here I'm going to continue to call another method, which is rename, and I'm gonna rename the label of the data frame. But here there are two axes of the labels to rename. You can rename the columns, which is axis 1, but you can also rename the index values of the data frame, which is axis 0. And I only need to rename axis 1, so I can here put in the name, the map. As for how do I want to rename the label from what to what, use a dictionary. But also I need to specify that the axis will be 1. Instead of doing that, I can also call the argument columns equal, give a mapper. In that case, I'm specifically wanting to rename the column names, so the program will not be confused about which axis am I changing. I'm going to rename the index column label to ID, and in the end I will have an ID column in the data frame, or supposedly maybe on the first row because it was resetted index values. And before you run it, make sure that you assign this resulting data frame back to mpg. Otherwise, the mpg will not be changed. Okay, so let's run it. And program is run, no errors, and let's check the data frame now, the first few rows. Wonderful. As you can see, an ID column is created. Now you have achieved your purpose here. Now, sometimes when the data frame has a lot of columns, you like to make it easier for you to apply the same kind of transformation or pre-processing operations on a group of variables that share the same type. So sometimes you would prefer to name the variables smartly by adding a small prefix to the variable so that you can quickly apply the same operation on those columns. And for example, I have applied some kind of operation relabeling here. As you can see, I have used cat, C-A-T, to designate this is a categorical variable. I've used txt to indicate this is text, even though this may be categorical, but there are too many categories. There are too many unique types of models, and each of the model name are different under each manufacturer. So this variable may not really be useful at this stage, cannot really be effectively included in any of the supervised learning methods. So I have used a prefix text to denote this column, and I have used int to indicate that this is potentially an interval variable. This is engine displacement. It can take quite a few number of different values. For years, it's interesting here. It's a little tricky, although years look like it's interval data, it's integers, but you can't really expect to use year as a typical interval variable here, because as the year increases, it's a time that is passing, not that something is increasing. So you would not expect the target variable to continuously and linearly correlate with this year variable. So year type of variable needs special treatment, and that's why I have denoted a dt, means date and time, date-time type of variable here. Cylinder is categorical. There are only a few different types of cylinder, a number of cylinders. Transmission type, categorical. Drivetrain, categorical. The two MPG variables are very much interval or continuous, so I've used int to denote that. Fuel means FL means fuel type, it's categorical. And class, excuse me, I'll fix this. I have accidentally named class into compact. It should be categorical type of class variable. And the way I changed the labels is by using a mapper, by specifying the before and after values of the column labels and passed into the rename method of the data frame. And now I'm going to reverse this compact. Actually, you know what? I'm going to rerun from the beginning. Now I've fixed that, and let me run this, and if I print this, you can see that the label is fixed. I would like to talk a little about the difference between single and double square bracket. As you can see here, you probably have thought about and have dealt with some of these instances in your homeworks and in your self-practice, and you may be confused, or you may have get the trick, and here I'm going to clarify their differences. So basically, a pair of single brackets means a list notation. So whenever you present a pair of single bracket, you are providing a list together with a bracket. However, if there are pairs of square brackets inside a pair of single bracket, that is lists within the lists. Now, what does this mean to data frames? In terms of slicing data frames, or slicing the columns, or slicing the rows of data frames, single brackets and double brackets could mean tricky businesses here, and let me demonstrate. How to get a series of column interval highway, so highway MPG as a column. If you want to get the column as a series, because each of the columns inside a data frame is by nature all series, so simply by calling the column without even using lock or ilock, simply using a pair of single bracket and slice this column, you will get a series. And let's see. As you can see here, I have sliced MPG interval highway, and I have confirmed that the returning object here is actually a series. So by using a pair of single bracket, it returns a series. What if you use a pair of double brackets to slice the same way as before, only the interval highway MPG? What will the result be? Let's check that out. And when I check if this returned object by using a pair of double brackets is a series, it returns false. It actually is not a series, but let's see. It's actually a data frame. So now you can see what is happening here is that when you do MPG slicing notation, it's trying to slice something here. It indicates that you want to slice something. You can and by not using the lock or iLock, you are specifically slicing the columns here. For data frame, it's slicing the axis of 1. You're slicing the columns. But for series, if MPG is a series, then you're slicing the index objects. So by default, it's behaving like that. And instead of putting one column, or instead of putting a label, a string label, into the slicing and indicating it's a single column, thereby that will return a series. Instead of doing that, you are slicing a list notation, and you are calling the program to put everything that is returned in a dimension and create another dimension. So that means whatever is returned back, it will have 2 dimensions. So then, if I put the list of one label into it, it will return a 2D object that will become a data frame, but only has one column. And let's check the shape of it. So it has 234 rows but only one column. And by contrast, if I were to get the shape of the series as returned by the slicing of a one column only, I will get only one dimension in the shape, like this. I only have one dimension, and this notation of series here is called the shapeless feature, and it is kept this way because it allows the series to be versatile when it is broadcast in terms of the both axes. So that is a benefit, but it does create some confusion in terms of series dimensions. I also would like to talk a little bit about list comprehension. Besides list comprehension, there's also dictionary comprehension and tuple comprehension, and set comprehension. Every native Python data object has a comprehension function here. So I'm using list comprehension as an example because list comprehension is used the most often. So what about list comprehension? List comprehension allows you to do effectively a for loop, but without using more than one line. For a simple list comprehension, you can achieve something very quickly by eliminating one line. And moreover, you can even achieve list comprehension inside list comprehension. So 2 levels of for loop in one list comprehension, thereby avoiding the need to create 2 loop, a loop inside loop, a double loop, by using more than 2 lines. A double loop will need at least 2 lines because you need to do something inside the loop. So here I'm going to show you quickly how to do list comprehension and also 2 levels of double loop inside one list comprehension, and demonstrate some use cases here. Now the first task with list comprehension is just going to demonstrate to you how to use it by doing a simple filter task. As you can see here, I have a list of numbers, integers. This is a very simple example, but hopefully this will demonstrate the usefulness of list comprehension. Let's say I want to select those even numbers. I will get rid of all the odd numbers. How can you do it with this list? Probably you're thinking about a for loop. Definitely, you can use a for loop to do that, and you probably need 3 lines without using semicolon. You can use 3 lines to and use a for loop to do that. And first, you will need to create a empty list, and then you will loop through the integers in this list, and then you'll use the modulate operator to see if the number is odd or even. So that would be the simplest way by using a for loop. And here I'll show you how to use a list comprehension in using one loop. Now, beginning to use the list comprehension, the first thing is to type the list notation, and you'll have the statement inside this notation. And the output of this list comprehension notation will be the result list. And beginning to use list comprehension, it's similar to doing a for loop. So num in list demo. This is for num in list demo, and this is sort of like a for loop, but instead of using a colon and break the line and write the statement in the next line, you'll write that statement before the for statement. So if I were to only simply retain those numbers as is without doing any operation, I will type the element here, but then I need a condition. Only if the number is an even number, I will retain it. So here you go. You add the if statement in the back of the list comprehension. If num modulate 2 equals 0, meaning there is no remainder by doing this operation, and that means the original number should be an even number. And if I were to run this line, I will get a list. And so if you want to assign the result to some result list, don't forget to do that. And now you can do that, and to confirm the result list, there are only even numbers here. So I have demonstrated a simple list comprehension, but the power of list comprehension is far beyond this. A good use case of a double loop inside a list comprehension is when you want to flatten a list that potentially has lists inside the list. And here is an example. And as you can see here, the list, I have a list for demo. This list have other lists as members of this list. So there are 2 levels of lists here. How do I get rid of all the inner lists and put the numbers in each of these inner lists together as members of the outer list? And by the end, I only have 1 level of list. I know that you can use 2 for loops, but using 2 for loops, you will probably need at least 3 lines of code. And first, you will need an empty list. Second, you will need a first level for loop, and then for each of the members in the outer list, you need another for loop to loop through the members of the inner lists, and then for every number, you will add that to the empty list, and by the end, you will have a list. So you at least will need 4 lines of code. I will show you how to use list comprehension to do double for loop in only 1 line. As usual, you'll use a list notation here, and then I will start typing by going for num in list demo, and notice that here all the members of the outer list is no longer numbers, so I might as well just update the name to be object. You can also probably use for list in that, or for list 1 or whatever for list, Here I'm going to for group also, because the members of the outer list are somewhat like a group, or even though sometimes it's one member group. For each of the group, and once I have the group that loop through the inner lists, I can loop through the number in every of these group. So by now the group is defined, and now I don't want to specify any condition because I'm not filtering the numbers in any way. I only want to retain everything. Before you run, make sure that you put the target element into the beginning as the member for return for the output list. And what I want is the num object here as each of the item of the resulting list. So here you go. If I were to run this, you will get a list of 1, 2, 3, 4. There you go. And if you want to assign it to something, don't forget to assign that. And if I were to compare this with the original list demo up there, it should return a true result. There you go. And one more thing I like to show you. Sometimes when you pre-process the data, or when you try to manage multiple data frames, and sometimes you need to only extract one column of things without getting the index values of one data frame and assign it to a new data frame so that you will retain that new data frame for later data analysis. Data frames have index values that are good in keeping and tracking the integrity of the data, but sometimes it's annoying because it tries to police too much, try to be a policeman too much and prevent you from assigning values across different data frames if they don't share the same index. And in those cases, you don't want to change the index values of the old data frame. So this becomes harder and harder with data frames, with the whole data frame object. And as a solution, you can cast, or you can convert whatever you want to copy across and convert them to be simply a list or a NumPy array, and then do the assignment. In that case, as long as you can make sure the dimensions can match, or even if it can do broadcasting, if the dimensions allow broadcasting, and if that's the way that you want the copy to go ahead, you can do that with the converted list or array. And here I'm going to quickly show you how to do the conversion. And again, you can see that I have the MPG data frame, and I simply would like to copy the year column and copy into another data frame, assuming the rows will match, but row index will not match. So I only need to extract the values of the year column, and in that you can simply use the series method toList or toNumPy to do that. And by slicing the column, and by using toList, you will get a list of the values by following the order of the original column. As you can see here, the entire list, and the first few values will match. 1999, third row is 2008. Alternatively, you can turn it into a NumPy array that is one-dimensional array. As you can see here, it is one-dimensional in the array because there's only one pair of square brackets, and the first few values will match the values here. All right, these are the several tricks I'd like to show you. Over time, I probably will think of more things that are that I use routinely in my daily research work in pre-processing or cleaning the data set, and when I think of those, I'll share with you. All right, I hope you enjoyed this video, and before I finish, I would like to encourage you and remind you to complete the official course evaluation survey, and I would like to encourage you to support the college and the department and me as well to get the feedback and to know that everybody is, holding strong, everybody is learning well, and also provide your valuable feedback about the course. The way to complete the survey specifically for this course is easy. I have created a link in Blackboard course. Simply go to Blackboard course and click on this course, BZAN6355 or BZAN4937 if you're undergrad student. And inside the Blackboard course, on the left hand side, the navigation menu on the very top, maybe the first one or the second one, I have created a blue link that says My Course Eval link, and by clicking that link, you will go directly to the course evaluation form for this course specifically, and it only takes 1 or 2 minutes. And as of now, I can't see your specific feedback. Of course, I can't see your individual feedback. It's anonymous, but I know roughly how many have completed. And by now, I saw that about 35% of this class have completed. Can you help me to push this up to 100% so that every one of you are showing positive support for the college and the department, by providing feedback to us, and for us to be sure that you are doing well in this course and you are progressing well and you are actively learning. Thank you so much. I hope you have enjoyed this video. See you next time.